All right, guys. I want to pick up where we left off yesterday. Today we're going to talk about some proofs using side, angle, side. What I want you to understand, though, because it's going to seem at some point that because of all the postulates and theorems that we learned that have 3 letters in them, S's and A's, that it might seem like we could just kind of haphazardly just use any collection of letters, S's and A's, and come up with a theorem or postulate that shows congruency. And I want to show you that that doesn't happen all the time, okay? So I'm going to use what is referred to as angle, so the AAA, all right? And I want to show you that just choosing those pieces of my figure to be congruent does not guarantee that I'm going to have congruency in the polygon, okay? So hopefully this picture here kind of demonstrates that. If I take angle A and I start to just kind of replace it over there, okay? Angle A and A prime, would you guys agree that those look like the same angle? Okay? And I think I can do this. I can match them up again. We do that. They do match up, right? Okay? So they are the same angle. Here, put it right there. Would you agree that angle B and B prime are going to be the same? And then I'd have C and C prime. Is that all right, everybody? So let's say that I gave you, I talked about this yesterday, if I gave you like 3 sticks or 3 pieces of yarn and I had to make a triangle, you're only going to make the same triangle, right? They're going to connect endpoint to endpoint. If I gave you 3 kind of cardboard cutouts of those angles, those blue angles on the right, A prime, B prime, and C prime, and asked you to create a triangle and then deconstruct it and create another triangle, the span that you put between those angles will not always be the same, will it? Meaning that if I connect C prime to B prime, okay, I could legitimately make those closer together if I wanted to, right? Does that make sense? Same thing here when I make the other one, okay? I could either expand the distance between A prime, B prime, and C prime, or condense it. If I leave it this way, are those 2 shapes congruent? No. Okay. Obviously, when I put them on top of each other, the congruency idea is that when they're on top of each other, they should be all parts overlapping, right? We see that the segments are not completely overlapping. Okay. Corresponding segments do not become congruent. So when I have angle, even though I've got corresponding angles congruent, it does not produce corresponding sides to be congruent. Okay? So angle is not a congruency theorem or postulate. Does that make sense? Okay? For the same reason, something like side angle will not be a congruency theorem or postulate. Okay? The ones that we've talked about so far, just go back to, see if I can open one of these up. Side angle side. So yesterday we talked about this one. If I were to give you, in front of you, a piece of string, okay, or a stick or a yardstick or a ruler or something like that, that is of some length, and then I give you a cardboard cutout of an angle that I'm forcing you to use, and then I give you another stick or another piece of string or whatever to create a second side, and if I tell you to put them in that order to one another, blue stick, red angle, black stick, okay? Every single time you do that in that order, you're always going to get the same exact triangle. Does that make sense? Okay? And what that does, looking at those 3 parts, it forces the other parts to kind of fall in line. It forces the other things that we haven't talked about, the other angles in the red segment, it makes them end up being congruent. Okay? Where if I have angle, that doesn't happen. The congruency on the segments of the parts that we haven't talked about is not guaranteed. Okay? When we look at side angle side, we have those parts. We are guaranteed then that this segment here is going to be the same as that red one. That this angle A prime is going to be the same thing as angle A, and angle B is going to be the same as B prime. Okay? It's guaranteed with side angle side. Those things are guaranteed with side. But with angle, not guaranteed. Okay? And that's kind of what I want to talk about throughout the next couple of days is the arrangement of sides and angles that will guarantee congruence, and then the ones that will not guarantee congruence. Okay. Now, angle. You could. Okay. It's probably kind of hard, but you could create a triangle with angle, deconstruct it, and then just by happenstance create the exact same triangle. That could happen. Okay. Congruence does occur sometimes with angle, but it doesn't occur all the time. Does that make sense? Okay. And that's the issue. We want to write theorems or postulates that something happens all the time, not just every once in a while. Okay. So that being said, I want to get into actually practicing and using some of these things. Okay. What?
That makes sense now.
Good.
SAS, you go like side and here's the angles and the side. I just now got that.
Good. Okay. So the order. So what Trey's saying is the order of the letters in the name tell you how the shapes or the parts have to show up in your picture, right? Okay. So that's always something to keep in mind as we're going through these proofs. And we're going to see that, hopefully, talk about that a little bit more once we get this proof kind of finished. This proof is not too bad. This one's actually pretty easy. I want to kind of set the stage for how we're going to start dealing with proofs from now on. Okay. Predominantly, when you see triangles in your picture, you're going to want to try to prove triangles somehow. Okay. And right now, we've got two tools, that side, and side, angle, side. Eventually, we'll continue to add things to that that open the door to use some other configuration of parts. But right now, side, angle, side. So look at this. Look at the picture right away. We got triangles. Let's prove triangles congruent. Okay, and that does match up to what we want to prove here. So that kind of logic makes sense, at least for this one. That being said, that does not mean that we don't necessarily have to think about maybe angle addition at some point, or segment addition, or parallel lines, the kind of individual proofs that we've done up to this point, because they will be involved, and that information regarding that stuff will be involved in some of the proofs that we do. But that'll be down the road when we start trying to increase the difficulty of these, challenge ourselves a little bit. We'll use more of those properties and theorems we've already kind of discussed in detail. If I'm trying to prove triangle congruency, the overall task then is to show three congruencies. Okay? Because every one of our postulates or theorems that we deal with is going to be like side, or side, angle, or angle, or angle, side. There's always three letters, right? And each one of those letters, like for side, each one of those S's represent one congruency, a side congruent to side. And then the second S represents a side congruent to another side. And the third S is a third side congruent to the third side. Does that make sense? So we're going to need in our statements, if I'm going to ever use side, I better have in my statements, in my left-hand column, three side length congruencies listed. Okay? If I want to use side, angle, side, I'm going to need three congruencies, two of which are sides congruent to sides, and one being an angle congruent to an angle. Okay? So that's kind of the process. Does that make sense? Prove triangle is congruent. You want to then write down three statements on the left-hand side that have congruencies in them. The way that we get our congruencies is going to be a little bit of a mixture of them just blatantly telling you. Okay? Do they kind of blatantly tell me two of my congruencies here? Okay? So that's nice. I'm going to write that stuff down. They give me two of the three congruencies that we need to figure out. If they don't blatantly tell me them, they're going to hide them. They're going to imply them in vocabulary, inside other postulates, other theorems, that type of stuff. They will, without doubt, somehow give me three congruencies, right? I'm going to have to shed light on them. These are pretty blatant, pretty obvious, okay? Now, it becomes a very, 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 very critical juncture in regards to our proofs that we start highlighting our congruencies in our pictures, okay? So every time that you come up with a congruency on the left-hand side, you need to come over to your picture. You need to draw it in, okay? Because at the end, and we'll come back and we'll look at this through the eyes of the person that didn't draw stuff in, or just kind of haphazardly drew some of the stuff in, but not all their congruencies. and talk about then how hard or how difficult it would be to make a connection about what postulate is existing. Okay, so we got that. Now, they also say that BAC, angle BAC, which is that red angle, is congruent to angle DCA, which is that red angle. Okay, obviously they have to use 3 letters there, right, when they name them, and we're going to start seeing more and more of that. We're going to move away from naming angles by 1 letter, because if I name just angle A, say everybody look at angle A, could everybody look at the one that I marked? Could have everybody looked at that one? Or could I have people looking at that black one? Okay, there's 3 angles there that have angle A, or vertex A. So I don't want to call it A, I want to call it BAC. That's the only angle that I would trace out then by going from B to A to C. Okay, so we've got to use 3 letters. But that's how many congruencies? That's 2. Okay, and so far, we've talked about side, 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 and side, angle, side. Hopefully you realize that this one's probably set itself up to use side, angle, side. Because it's got an angle involved, right? Okay. Now, as the more of those things that we learn, maybe you can't start to narrow in halfway through and say, I know I'm going to use this approach because of the letters that are being used. But this one we could probably argue that side, angle, side is going to be the approach. We look at our given, write all that stuff down, write all the congruencies down. Then we look at the vocabulary that's within that given. There's no vocabulary, right? Okay. So then we look at our picture. Okay. And I've talked about this before. When you look at your picture, there's a handful of things that you can determine from a picture. You can talk about vertical angles, you can talk about linear pairs, and you can talk about common shapes being shared. Okay? What is common up there in both triangles? Alex? Okay, so you're saying we got, and we do, if I look at this here and that there, because the red angles are alternate interior and they're congruent, we could say that AB is parallel to DC, right? That's absolutely true. That's fine. There's nothing wrong with that. And that might actually be something that we do later on to maybe gain a different congruency here. Okay. But look at what's shared. What part up there? Yeah, AC is in both triangles, isn't it? The segment in the triangle on the left, and it's a triangle, or it's a segment of the triangle on the right. So if it's in both triangles, if the entire segment is in both triangles, we probably want to make note of that. We want to write AC is congruent to AC. Is that fair to say? That something's always congruent to itself? Yeah. Now, hopefully you see the benefit of that. If I go ahead and draw that in my picture, okay, we get that. We now have how many congruencies on the left-hand side? We have 3. Okay, we have 3 congruencies on the left-hand side, which is nice because now that tells me, look at your picture and see what the order is. Okay, if I was not drawing these in, if I was being lazy and I was writing these down, but I wasn't drawing my pictures, is it going to be kind of hard to look at my picture and see what my picture tells me? Okay, but if I am drawing stuff in, is it kind of easy to look at my picture and say, in this triangle here on the left? So you maybe don't do this every time, but I want to kind of just look at the one on the left. You have a side, an angle, and a side being marked. Okay. Then I want to make sure that I have the same exact thing happening in the triangle on the right. So if I look at the triangle on the right, do I have a side, an angle, and a side? Okay. So because of that, we can see that these 2 triangles are congruent to one another. Because of that postulate we talked about, says side, angle, side means that 2 sides in an included angle of one triangle are congruent to 2 sides in an included angle of another triangle, then the triangles are congruent. Okay? Should have said that was reflective, right? AC equals AC, or AC is congruent to AC, that's reflective. But now it looks like that provides us the picture then that gives us these 3 parts congruent to these 3 parts. Whenever you have that, okay, we're going to say that triangles are congruent. So you're going to name triangle ABC, congruent to triangle CBA. And whenever I say that 2 triangles are congruent, it's going to be because of a theorem or a postulate that is written using 3 letters. So what would be those 3 letters, and what would be the order of those 3 letters? SAS. Okay? So side, angle, side. But one thing I would want you guys to make sure to pay attention to, because at some point we'll see it even today. Once we knew at these two triangles we had the SAS stuff, I just kind of looked up here what we wanted to prove, and I just wrote exactly what I wanted to prove. Okay. A lot of times though, we're going to write down we're kind of name this one any way that we want to, the one on the left, so ABC. Naming the one on the right, then, if I started at A, I know I got to start over here at C, right? Because they both have one mark in them. Okay. Then I went to B. Okay. Now B, from A, I went down the segment that had one mark in it, right? So when I started here at C, I've got an option to either go to D or to A, right? But to correspond to what I've already done in the first name, I got to go down the segment that has one mark in it. Does that make sense to everybody? So I start at C and I go to D, and then obviously I have to finish at A. That's no other option. So the structure of naming those things is going to be extremely critical to us. Is that all right? Okay, so that's kind of the general process for any one of these proofs that we're going to do with triangles. Okay, now they're going to hide stuff. They're not going to give us the stuff that I have up there in yellow. They're not going to give it to us that easy. Okay, we're going to do a little bit of work for that. One thing I want you guys to pay attention to, at some point you might get something like this where you've gone through and maybe it's a proof, or maybe it's just a homework question that asks you to decide whether these two triangles are congruent or not, and you're going to have this information. I'm going to give you that stuff in that triangle, and then I'll give you that stuff in that triangle. I'm going to ask you, are these two triangles congruent? Okay? And the argument then is, well, if I cover up that triangle, what parts do you have over here? What parts would these three be? You have side, angle, side, right? Okay. You also have maybe side, 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 don't you? And that's one thing that does happen, is that you can start to see with two triangles, then you've got more than one way of proving the congruent. So let's just focus on the side, angle, side. If these two triangles are going to be congruent, guys, then when I look at that other triangle, I got to have the same parts in the same order. I still have two sides and I still have an angle, just like I did in the first one, right? But are they in the form of SAS? Is the angle in between the two sides that I've identified? No. Okay. So even though I've got the right number of parts, and two of them are sides and one of them is angle, just because they're in the wrong order, though, it's going to say we don't know if those triangles are congruent. Okay. Does that kind of make sense? Okay. That's something that you always want to kind of pay attention to as you're working through your proofs here. I check to see if that one had SAS, and then I check that one to see if it has SAS. If they both have the same order of parts, then indeed they are congruent. If one's SAS and the other one's AAS or ASA, something like that, or SSS, they're not congruent. Okay, or at least I don't have the information yet to show them congruent. Okay. Let's do one where it's a little bit less informative on regards to the information they give us. I'll give you a little bit of time to write that one down, draw a picture. And then when we're done with this one, I actually want to kind of talk through what this one actually gets us to. This one actually ends up being one of the kind of fundamental proofs that provide us a lot of information that we're going to use throughout the rest of the course. Okay, and it's not really all that bad to deal with. It's actually pretty simple in regards to showing those triangles in a row. How's my day been? Fabulous. My days are always good. Huh? Yeah, that's the reason. Yeah, that's what lets you sleep at night. Huh? You know what make my days better? No. You came to baseball workouts? putting that out there.
It wasn't supposed to be bad tonight. I heard we're supposed to get some tonight.
We were supposed to get some last night.
I thought we get like 4 inches. Yeah, I'm like really tired tomorrow.
You just had 3 days off.
Exactly.
You get through this week.
Yeah,
Dude. All you gotta do is get through this week. Next week will be a breeze.
No, next week will not be a breeze because I will have to use the water. Presentation in Molar. Yeah, the presentation in Molar.
I thought next week we go back to normal. Well,
no.
Oh, you won't have it.
Yeah,
Okay.
I didn't know back to that. I would say.
All right, so in this one, in the given, I write that you have xz congruent to yz, right? So there's one of the 3 congruencies that I'm probably going to need at some point in showing these 2 triangles congruent to one another, right? Yes. No. So we fill that information in. Next thing we do is we look at the vocabulary, right? What's the vocab word? Midpoint. Okay? Now, midpoint, every time you see that vocabulary word, as if we've never done this before, but we've seen a lot of these, right? We've seen midpoint being used over and over and over again, right? Every time I see the midpoint word, what it gives me today is the same thing it gave me 3 weeks ago. It's the same thing it's going to give me 12 weeks from now. Does that make sense? It's always the same. When you see midpoint, it's providing you 2 segments that are congruent. For us, which 2 segments would that be that are congruent here? XW and WY, right? All right, so if that's a midpoint, if W is a midpoint, it means that segment right there and that segment right there have to be the same length. Okay? Do I know those lengths? No, I don't know what they are, what numbers, what value we use to describe them in regards to their distance or their measurement, but I know they're the same because that's what a midpoint does. That's how we define a midpoint. Okay, so we have the this would be the reason, definition of a midpoint. What did that do? That gave us another congruency, right? Now we've got 2 of our 3 congruencies. You see how that one was hidden in the vocabulary word? All right. So the last example we did, everything was explicit. That congruency was implied. Okay? Look at my picture. All right, because we've run out of vocabulary, right? Well, look at my picture. What can I tell from my picture? Okay? Okay, ZW is congruent to ZW. Why? Okay. Now, here's the thing, guys. I had people earlier saying, and I'll put a number in here, but they said like ZWX and ZWY. They said angle, I'll just call them angle 1 and angle 2. They said angle 1 and angle 2 are a linear pair. Is that true? Is angle 1 and angle 2, are they a linear pair? Absolutely, they are, right? If you wanted to put that in there, put it in there, that's fine. But in the scheme of trying to prove triangles congruent, we know we got to show 3 congruencies, right? Well, showing a linear pair is not showing me congruencies. Does that make sense? So even though it's true, hopefully that's not something we try to target and look at because we know we're on the task of trying to show congruencies and not linear pairs at the moment, right? Now that's not saying that down the road that might not lead us to congruency, but right now with this, looking at, because when I look at a picture, we've got several tools we can use. We can decide by looking at a picture that 2 angles are linear pairs. We can decide that angles are vertical, and we can decide reflexiveness. Okay, if that's a word. I think it's reflexivity. Is that a word?
I don't know.
Okay, the property of being reflective. We got those 3 things right now that we can look at a picture and determine. In regards to trying to prove triangles congruent, addressing the reflective property is probably is paramount. It's what we want to look at first. Is that all right with everyone? Okay, keep that in mind. I'm trying to give you a structure of how you approach every one of these proofs. Sure.
Really dull.
Actually, here, wait, because it's going to be probably a nuisance. So here.
No, it's fine.
No, I got you one that never dull.
I don't like mechanical. No, I don't like mechanical.
Live with it.
I have more pencils.
All right, so ZW is near to ZW. So look at the picture now, guys. If we were to cover up the triangle on the right, what are those parts that I have over here? Side, side, side. If I were to cover up the one on the left, what are the parts that I have now on the right? Side, side, side. So are those two triangles congruent then? Yeah. Okay. So we have, once I have one congruency, two congruencies, three congruencies written in my statement, I can probably target the triangle. What do you want to call the triangle on the left? XWZ, absolutely fine. XWZ. And now if I name that one XWZ, what is the one on the right got to be called? YWZ. Good. All right. Again, just to make sure everybody's on the same page, start at X. Johnny said start at X. Go to W. Okay, so you started at X, which was the angle that was stuck between one mark and two marks, right? So then over here, I got to start at the same angle, the one between one mark and two marks. So it tells me Y. He then went to W, and naming the first one, X to W. The Y traveled down the segment that had two marks. So don't I have to do the same thing in the second triangle? Travel down to W, which will take me from Y to W down the line that has two marks in it. So I go Y to W, and then by default, I got to finish at Z, right? Okay. You have to do that process every single time you name these figures. All right? And you're going to hear me harp on that and say that over and over and over again because I know that 90% of us probably already get that. If they say, shut up, I've heard enough of it. Okay?
Amen.
But there's still 10% of us out there. There might be 2 or 3 students every year that they need to hear that. And they need to see that over and over and over because they want to just haphazardly just say, I'm going to name them any way that I want to. Okay? So I'll make sure that we're all on the same page here. So what is my reason when I show triangles congruent? There's always a 3-letter reason. What's my 3-letter reason here? Side, side, side. Okay? It's just a structure. Every time I show triangles congruent, guys, my reason over here will always be 3 letters. Always. Okay? If I go to that statement number 4, is that exactly what I wanted to prove here?
No.
No. If I look at what I wanted to prove, this is kind of the thing that you do. Every time you get triangles congruent, I want to go back up and see if that matched to what I was asked to prove. And it doesn't, because the shape that I just highlighted out front on the bottom is a triangle, right? The shape that I highlighted green up top is a angle. Okay? But if the triangles are congruent, by side, 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 isn't a conclusion of that say that all the corresponding parts should be congruent? So the angles that we have not mentioned, the groupings of angles that we have not mentioned throughout this entire proof, we absolutely know, or they have to be congruent to one another. Okay, that's kind of the definition of congruent figures. Okay, so once I show triangles congruent, then corresponding parts are congruent as well, right? Now all I got to do is see if XZW, XZW is at the same angle as YZW. And if I've got my names written right here correctly, I'm just going to kind of repeat a process here. If I go X to Z to W, that's kind of the pattern there, right? Does that make sense? Start the first letter, go to the last one, come back to the middle. Does that go Y to Z to W? Is that the name that I wanted there? Does that make sense to everybody? If you've got the names written correctly, and then I just give you 3 letters out of one of them, you should be able to follow that same pattern of those 3 letters to find the corresponding angle in the other. Okay? So that allows us to say XZW is indeed congruent to YZW. Anybody know why? Good job. C. Corresponding parts of congruent triangles. So XZW and YZW are essentially matching parts from congruent triangles, right? And the matching parts, the corresponding parts from congruent triangles have to themselves be congruent. That's what the definition of congruent triangle says. Okay? Is that all right with everybody? Triangles. Corresponding parts. Okay, so corresponding is the C. Parts is the P. Congruent is the first C. T. Oh, I see what you're saying. Polygons. So if you put CPC there, guys, that's fine as well. And maybe even some of your homework questions that ask proofs that are pulled from other textbooks, they might write a P there, or they might say write out in words, corresponding parts, congruent, polygons are congruent. Those all say the same thing. They're all analogous statements. All right, so here's my question. Let's go a little bit further with this. And we don't have to write anything here, but let's go back. Let's say I put we did have angle 1 and 2 here earlier that I wrote down there, right? All right, what was the fact that we said about angle 1 and angle 2? They were a linear pair. Now that I know those triangles are congruent, let's look at XWZ. XWZ, is that congruent to YWZ? Okay, so angle 1 is XWZ, angle 2 is YWZ. We just shown now that we have a linear pair, but both those angles are congruent, right? Okay, so if they're congruent and they're a linear pair, what does each one of them have to be? 90. Does that make sense to everybody? Okay, so the purpose of ZW. Good. Yeah. ZW. Let me write this. ZW is perpendicular to XY, right? Yeah. Okay, here's my question. Overall triangle, XZY. What kind of triangle is that? It's two congruent sides, right? Yeah. So it's isosceles. Okay, let me ask you this question. That blue line, that blue vertical line, ZW, what does it do to that top purple angle? Huh? Makes two angles that are what to one another? Congruent. Okay? Because angle 1 is congruent to angle 2. X and Y are congruent, right? So then angle XZW and angle YZW are also congruent. Okay, so here's what I'm saying. Okay, we call angle Z of that overall triangle, we call it a vertex angle. It's the angle that's between two congruent sides in an isosceles triangle. You don't need to write this down. We'll get to it later on. I want to show you where this stuff's going to come into play. We call it a vertex angle. If we bisect the vertex angle, so ZW is bisecting the vertex angle, then that bisector ends up being perpendicular to the base of my isosceles triangle, and it bisects the base of my isosceles triangle. And that guy sets the precedent for a lot of stuff that we're going to do later on with things called special right triangles, with work that we do inside circles and all that kind of stuff. Okay? There's a lot of information that we can kind of gain from basically saying those two triangles are congruent, and then saying, okay, well, we got linear pairs, so linear pairs got to be congruent. So that means we've got to have 90-degree angles, we've got to have perpendicular segments, okay, and all that kind of stuff. Okay? No, it didn't. It sounded like that might have hurt. But you guys kind of see the purpose of our proofs here? We're trying to make these relations. Once we show triangles congruent, then we can start seeing all of our other facts that we've learned in sections or chapters 1, 2, and 3 kind of fall into place, and it allows us to talk more about these triangles and determine more facts about them. Okay, which is very nice. Down the road, okay, so I told you kind of different ways that they're going to give you your information. So instead of telling you this down the road, instead of saying XZ is congruent to YZ, they might just tell you triangle XZY is a isosceles triangle. Does that make sense? Okay, so instead of being blatant with that congruency, instead of being explicit with that congruency, they might hide it in a vocabulary word. They won't do that until we get to section like 4.3, 4.4, because we have to actually talk about some of the components of an isosceles triangle, some of the legs and base of it, but that is kind of where this stuff's going to lead. I give this one a shot. Write this one down. We'll talk about it. Once you write down, if you want to come up with your statements that you get from your given, go ahead and do that.
What's your favorite kind of lemonade?
Lemonade.
What kind?
Lemonade.
What kind?
We don't call lemonade lemonade.
What kind? Yellow,
like which brand?
like raspberry.
No, lemon. Lemonade.
No.
Yeah. No, all I had to say was lemonade.
So I asked you what kind. Yeah, I know. Lemonade. It's just normal lemonade.
Yeah, I did.
Lemonade is not lemonade. That's like saying that's like saying soda is water. It's because it has water. Yeah, it's part water. Oh,
I love those types of conversations because there's so much math, the way we think about math involved in those conversations.
What's your favorite shape?
What's my favorite shape?
We all know you like it.
Because I teach this stuff doesn't mean I love it. I enjoy it.
You love questions like that, baby.
I do.
You love that.
But shapes are not the only thing in math. Like I prefer algebra. I'd rather my 7 hours a day be just pure algebra.
Like no lunch break or anything.
But
straight algebra.
yeah. But what I have found, guys, so understand that, I was in your seats at one point and going through all these courses and thinking these courses were kind of singular courses, that they were all by themselves. But what I found out later, after I went through them and had to go back through them to kind of understand some of the content and the ideas I'm talking about in new courses that I was in, kind of found out that they're all intertwined. And the better I understand geometry, and the better that I understand how to read theorems and apply theorems and take the information from them and use them, that helps me immensely in algebra. Because guess what structures all the processes that we do in algebra, like factoring and that kind of stuff?
Numbers.
Theorems. Okay? And the more we understand those theorems, we understand maybe how to read them and apply them like we're trying to do here in geometry, the better I got at algebra. Okay? So, and to be honest with you, that's kind of, I think, your number one thing that you're going to want to be skilled at when you leave high school in mathematics. If you are going to go on to a degree that incorporates some level of science or math, the algebra is the hardest thing of those things. Okay, you guys, I don't know if I told you this. You guys know what area is?
Yeah.
Okay, do you know what slope is?
Yeah.
Okay, I just taught you calculus. Okay, that's all you do in there. But the hard part of calculus is using the algebra to analyze slope and area. Does that make sense? Okay. So algebra is the number one thing that I think you should leave high school with. But in order to learn the algebra, I found that geometry and the mindset and structure that we learn in algebra or geometry allows for that maybe a little bit better. What?
Will you come visit me in college? Like every year.
No. Shut up.
Why don't you visit me?
Uh-huh.
Why don't you visit me? Like once out of every year.
Yeah, sure, I'll do that. All right.
Or you come visit me. So, what's your favorite shape? You never
I don't know. Triangle.
What?
Triangle. They create every other shape. Or they're involved in every other shape.
Yeah?
Yeah. Even circles. Huge component to circles is triangles.
No.
Yes.
Can a triangle fit in a circle, Trey? Yes. Trey, okay, Trey. How do you make a piece? Well, you agree with me that's a circle, poorly drawn, but that's a circle. Look. Take there. Go to there. No, not, you said the triangle, like what the circle is this? The triangle this way. That's Pac-Man.
All right, here we go. So doing this first. All right. So C is the midpoint of the AE. If C is the midpoint of the AE, just like what we saw the midpoint doing earlier, it gave us a congruency, right? What is our congruency? If C is the midpoint of AE, what parts are congruent there? If C is the midpoint of A to E, then AC is congruent to CE. If C is the midpoint of BD, BC and CD. Now I wrote my given, I kind of separated it into two lines, kind of that are saying very similar things. I wanted you to see that when they say C is the midpoint of the AE and BD, that there's actually two pieces of information that you get from that, right? Draw that in your picture, okay? So AC congruent to CE, BC congruent to CD, okay? Now, we've got two congruencies on the left-hand side. We need one more congruency. All right, look at your picture. Is there anything that overlaps? Looking at overlapping things is the number one thing that you want to look for. If that doesn't show up, the number two thing you want to think about and see is what? What do we see up there? Any other congruencies that you automatically know to be true? Vertical angles. Good. Okay. So I want to talk about that angle there and that angle there, right? Okay. Can I call it angle C? No. No. Okay. Because I say, look at everyone look at angle C. We don't know which one. And some people might even look at the one out here or down here. Okay. So what's the best way of doing that? Let's talk about those. Using three letters, right? So ACB and now I went ACB, and this you don't have to do this with naming angles, but I think it's a good idea because it's going to lead you into being able to name the triangles correctly. I went A to C to B. Started at A, went down a segment that has one mark in it, got to C, then traveled down a segment that has two marks in it and got to B, right? Yeah. I would try to follow the same directions when I name the other angle. So what would I have to start at? E, C, D, D. And now if I do that with those angles, guys, the only thing I have to do then when I want to show the triangles congruent is put triangle out front instead of an angle. Okay? Why are those two angles congruent? What did we say? Vertical angles. Is that the definition? Theorem. Theorem. Okay. Yeah. Vertical angles theorem says vertical angles are congruent. Okay. Look at your picture on the left. What's the order of parts on the picture on the left? What's the order of these three parts? Side angle side. The order of the parts on that side? Side angle side. Okay. So are those two triangles congruent? Yeah. All right. So let's name them. So now I said, as long as we name these angles in statement 3 that way, we should be able to just put a triangle out in front of ACB and a triangle out in front of ECD. You said side angle side. And we think we're done because that's what we set out to do, is we set out to show triangles congruent. We never looked at the proof statement. Always want to, when you get the triangles congruent, match it back up to the proof statement. Are they the same? And they're not, right?
It's the congruent parts of congruent triangles are congruent.
All right, so if angle A is the first letter here and E is the first letter there, they need to be congruent, right? Or they are congruent. Angle A is to angle E, so we get CPCCC. Is that all right? All right, so let's talk about some neat things that happen here. That's angle A, right? Yes. That's angle E, right? Yes. Let's say that we are focused on that information there. What kind of angles are they in regards to location to one another? Alternate interior. You've just shown alternate interior angles are what now? Congruent. And if alternate interior angles are congruent, what could you tell me about that segment there compared to that segment there? They're parallel. Okay. So those are things that the CPCTC stuff, when showing congruency of angles or individual parts, leads us then to things like parallelism or perpendicular angles like the last question, or angle bisectors and stuff like that. Does that make sense? Yeah. Okay. So we're going to spend a lot of time working through proofs like this, but what I want you guys to understand is that there's structure. Before I say triangles are congruent, I need 3 congruency statements to show up before that. Okay. If I need to go beyond showing triangles congruent, my next step always is a CPCTC statement. Okay. So you're going to see like statement number 4 up there, 2 triangles congruent. If that's not your proof, then the next step will 100% of the time be CPCTC. Okay. And then you can make a conclusion about that. And now I got A congruent E. Can I go further? Can I now say we got alternate interior angles? Awesome. We got parallel lines and that kind of stuff. So we'll continue to practice that and say, okay, now that we understand maybe these first 4 steps, okay, how can we kind of add on to that? How can we build onto that to get new facts, new information about these shapes that are occurring in front of us? You'll learn more. All right. So again, this is not a theorem, okay? Because may not see that picture ever again. But the purpose of doing questions like that is to get us to practice using, applying, analyzing our definitions, our other theorems, and our postulates, so that when we do want to use those to create new theorems or to prove theorems, we have that ability. All right. Section 4.2 is available. It was available yesterday. Make sure you have that finished up by tomorrow. We'll probably do a handful of proofs again tomorrow. Yes.
These triangles have split edges. A circle has triangles, like triangle pieces. Pieces have triangles.
Okay, so your question about triangles and circles, the relation of triangles and circles. Okay. So when I look at a circle, so let me put that point. Let's talk about the circle here. Okay. Right. So you're saying if I want to look at,
No, I'm talking about pizza.
hold on. If I'm looking at,
No, they're not triangles. They're cones. They're cones. Exactly. No, they're not cones. They're three.
so you're looking at that thing right there, right? You're looking at that shape right there? That is a set. We call that a sector. Okay. That is now a triangle, correct? But that triangle, listen, that triangle is isosceles. Would you agree with that? Is that the radius of the circle right there? That's the radius of the circle, correct? Okay. Knowing information about that triangle is going to tell me information about that slice of pizza. So circles directly link to triangles.
I know, but they're not triangles in pizza. No, he said that.
No, they're sectors.
Yeah.
You too.